Okay, so 7.3 deals with adding and subtracting rational expressions. So again, what is rational? Fractions. Okay, so we have to be able to add and subtract fractions. So one of the issues with not understanding the basic rules of fractions is where we are right now, because it's difficult for you to bridge the gap between the process of using it for fractions, basic fractions, to using it with algebraic fractions or algebraic rational expressions. So I'm just going to go over the basic rules of adding and subtracting basic fractions first, just so that we can just kind of connect the dots and bridge the gap to see how math really just evolves, right? So let's say that we have 4/7 plus 2/7. So when we are adding and subtracting fractions, the rules say the denominator must always be the same in order for you to add or subtract fractions. So on this particular example, my denominator would be 7. I would do 4 plus the 2. I would get 6/7, right? Yes. 5/8 minus 3/8 would be 5 minus 3/8, right? I'm just showing you the steps, but you can obviously just do 5 minus 3, which is 2, and just go straight to 2/8. But 2/8 would not be the final answer. Why? Oh, because it's not reduced to lowest terms. So what does that mean? That means I have to reduce it to lowest terms. So you would use whatever method you want to use. So we're just going to use breaking down by factoring. Why? Because that's the method we're going to have to use when we do these algebraic expressions. So 1/4, right? So just adding and subtracting rational expressions, the denominators must be the same, and all you do is combine the numerators. Okay, we can do that. We understand that. All right, so now let's look at these rational expressions that contain variable components. So let's look at number 1 over here. So we have 6/x plus 2 plus 8/x plus 2. So we have the common denominator of x plus 2, and then we're just going to take the numerators and put them together. So 14/x plus 2. So then when you look at your rational expression, you go back to your 7.1 rules. Factor where possible, cancel out like factors. So nothing needs to break down. 14 is 2 and 7, but there's nothing to cancel it with at the bottom anyway. So the answer would be 14/x plus 2. And I put the parentheses around x plus 2 just to help you remember that you couldn't cancel that with anything unless it was another x plus 2. All right. So then number 2, we're looking at 11x over 4y minus 5x over 4y. So it's different from the multiplying and dividing because these individual fractions, you can't really do anything with them because you have to perform the addition or the subtraction. So in theory, you could try to reduce them first, but that's not what we're supposed to do because you're not really going to be able to do anything. You're supposed to combine them to a single rational expression, then do your rules to reduce it from there. So single denominator is 4y, so the numerator would be 11x minus 5x. So we're looking at 6x over 4y. So when we look at this, the 6/4 can reduce. X over y is going to have to stay x over y, but 6/4 is 3/2. So 3x over 2y, and that would be it. Because what did I do? I did 2 times 3 times x over 2 times 2 times y, essentially. And then the 2's cancel each other out. Okay? All right. Then number 3, 8x over x plus 5 plus 40 over x plus 5. So the x plus 5 stays the same. The numerators are 8x plus 40. So this is my problem, 8x plus 40 over x plus 5. So when I look at the numerator, it can actually factor. So I need to factor so that I can see if this fraction reduces. So 8x over 40, so I have some scratch work somewhere, right? Remember, separate your page. So 8x plus 40, GCF of 8, x plus 5. So 8 times x plus 5 over x plus 5 So x plus 5 cancel with x plus 5. The answer is 8, and that's it. Problem is finished. So you combine, since they have the same denominator. Then you look to see if you can factor the numerator or the denominator. And then you see if you can cancel any like factors. And that's adding and subtracting when you already have the same denominator. So let's look at 4, 5, and 6 now. All right, so number 4, we have the common denominator of x minus 4. The numerator, x squared plus 5x minus 9x. So let's see. In the numerator, we actually have like terms, so we can simplify that. So you should not be trying to factor anything if it's not simplified to lowest terms first, right? So you look at your numerator, you look at your denominator, see if you can simplify or combine anything. So my numerator, I can combine. So we would end up with x squared minus 4x over x minus 4. So now x squared minus 4x can factor. So we get x times x minus 4 over x minus 4. So remember parentheses. What is happening? So we use parentheses. So x minus 4 cancels with x minus 4. What are we left with? Just an x. That's it. So you write the single rational expression. You combine like terms. And then you start your process over. So let's write that out. Hold on. Okay, so I wrote out the steps. So you can have them. Because remember, it's about the process. So that you can do any type of problem. So the first rule of adding and subtracting is really you're supposed to get your LCD. But for the ones we've been doing, we already have a common denominator. So we're good to go. So then you should write a single fraction with that LCD. So let's look at number 5. So the common denominator is x plus 3. We already had that. Then we're going to write as a single fraction. So 9 minus x squared is what we would have there. So then it says combine like terms as possible. So there's nothing I can combine. So now I'm just going to try to simplify the expression. And simplify the expression is our rules from 7.1. Which is factor where you can, because now this is just a 7.1 fraction, right? This is just one rational expression that needs to be simplified, and that's your 7.1 process. You factor where you can, and then you cancel like factors. So 9 minus x squared, first of all, is not in factor form. So I'm going to write it in its descending order, which is what you're supposed to do because it's rules of factoring, right? So everything has to come back into play, right? We got to know all our steps. Oh, I got to factor this. So I got to think, how do I factor it? Well, I'm going to write it in descending order. So I'm going to factor out that -1 because anytime your leading term or your leading coefficient is a negative, remember you always factor out the negative as a GCF. So when I do that, I'm left with -1 times x squared minus 9, and then x squared minus 9 is the difference of 2 squares. So when I rewrite this problem, I'm looking at -1 times x minus 3 over x plus times x plus 3 over x plus 3. So I'm going to put this in parentheses. So what cancels? X plus 3 and x plus 3. So what's left? -1 times x minus 3. That's the final answer. That's it. If you don't have the 1, you just have negative. That's fine too. But that's your final answer. Okay? All right, next. Now, number 6. Number 6 is our pay attention problem. Because we have something subtracting that has multiple terms. So we're really just dealing with the numerator. Please understand that when you're subtracting. So on this particular example, the denominator is x minus 9, right? Yes. The first numerator is x squared minus x minus 1. Then it says minus 5x plus 26. So what I want you to see is that there are invisible parentheses there, essentially, because this negative sign must what? It must distribute to everything behind it. But them not putting it is deceitful because you get confused and you don't realize you are subtracting the 5x and you are subtracting the 26. So everything behind it is going to go in parentheses. Okay? So when I look at it, I'm looking at x squared minus x minus 1 minus 5x minus 26 all over x minus 9. So I write it as a single fraction. Now I'm going to combine like terms. So x squared minus 6x minus 27 over x minus 9. So I combine like terms. So I have like terms in the numerator. Now I'm going to see if I can simplify this rational expression by doing what? By seeing if I can factor the top. Factors of 27, that'll give me a 6, 9, and 3. So x minus 9, x plus 3. Yeah, that checks. So once I've factored this, I'll rewrite my factors in over x minus 9. X minus 9 cancel with x minus 9. Final answer, x plus 3. That's it. That's it. All right, so the biggest thing is just to make sure when you see a subtraction, if it's more than one term behind the minus, that negative is going to have to distribute to everybody behind it. So I like to write whatever's behind the negative when it's more than one term in parentheses for myself and then distribute it, okay? Because you know it's always the little things. So 7.3, adding, subtracting rational expressions. And all of these problems were where the denominator is already the same, okay?